All right, example problem number 2. In a grocery store, you push a 14.5 kilogram shopping cart. It is initially rolling at a constant speed of 3 meters per second. You push on it in the direction that is opposite of its motion, exerting a 10.5 Newton force on it. Neglect friction between the cart and the floor. So that basically means you have your cart, which is going to be our object of interest. Okay, so we're going to isolate that object, is traveling to the right, and you are pushing it while it's traveling to the right to the left, which means it's going to get slower. All right, our change in velocity will be to the left here. So if I look at the shopping cart itself, we know that the floor is pushing up on it. We know that the earth is pulling down on it, and we know that you are pushing to the left. So to draw a force diagram of this, we have the force of the floor on the shopping cart, we have the force of the earth on the shopping cart, and these two are balanced, and we have you pushing it in the opposite direction at which it's moving. We have the force of you on the cart. All right, now to apply Newton's second law in component form. All right, so up at the top of the page, I had put in an x and y axis at positive x and positive y. Positive x is to the right, positive y is up, which means as I now write Newton's second law in the horizontal direction, we know that the acceleration, okay, in the x direction, we should expect our answer to be a negative value because the force that you are exerting is directed to the left. So I'm going to put a negative sign here and divide by the mass. Now, the way this works is if we now substitute in the 10.5 newtons of force, and it's going to the left, which means I need to include the negative and divide by the 14.5 kilograms, we should get an acceleration of 7.5 meters per second, but that is opposing the motion. So, and it's, according to this vector, it's pointing to the left, so this is going to be in the negative direction. In the y direction, all right, our forces are balanced, so the acceleration in the y direction will equal 0. And we have the force of the floor on the cart minus the force of the earth on the cart. And like we said before, that will equal to 0. There's no question that addresses the y direction, so we're just going to leave this as is for now, but we're going to keep setting it up because we'll need it as we learn more and more about different forces. All right, to address letter E. So the object is traveling to the right at 3 meters per second. So this initial velocity is 3 meters per second. But the acceleration tells us that it has an acceleration to the left at a rate of 0.75 meters per second each second, which means if the velocity is pointing to the right and the acceleration opposes that after 1 second, this is going to be down to 2.25 meters per second. It's changing by the 0.75 meters per second. And then once at the end of the second we'll be at 1.5 meters per second. So this negative 0.75 meters per second reflects the rate at which the velocity changes. And excuse me, and that's it. Time for number 3.